Hello everyone and welcome to the lesson. Let's solve this question on loci. Use a ruler and a pair of compasses only in this question. Part A, construct triangle ABC such that AB is equals to 6 centimeters, AC is equals to BC, and the angle ACB is equals to 135 degrees. 3 marks. Part B, on one side only construct the locus of P such that 1. Angle APB is equals to 67.5 degrees. 2. The area of triangle APB is equals to 9 centimeters squared. That is 2 marks. Then part C, 1. Locate P1 and P2, the two possible positions of P which satisfy the two conditions above. 2 marks. And the last one, measure the distance between P1 and P2. Now before we solve this question, the first thing that we're going to do is to have a rough sketch of what we expect to draw accurately before we go to the actual drawing. Now let me sketch it on a different sheet here. So we need triangle ABC. So triangle ABC. So let me draw it here. So we need triangle ABC. So that is ABC, in which AB is equals to 6 centimeters. So that is 6 centimeters. And then AC is equals to BC. AC is equals to BC. So this one is an isosceles triangle. And the angle ACB is equals to 135. ACB, this angle here, should be 135. That means the base angles here should be, each one of them should be 22.5. And this one should be 22.5, since 135 plus 45, that will give 180. Then from there, what else do we need? So that is the first thing that you're going to do for part A. So we need to construct this triangle with those angles, and the measurements AB is given and the angle. So this is what you're going to do. Because you're supposed to use a pair of compasses and a ruler, how do you construct an angle of 22.5? So for 22.5, we shall begin by constructing 90 degrees. Then we bisect 90 degrees to get 45. So that will be 45. Then again, we will bisect 45, the other 45 that is remaining, in order to get 22.5 and 22.5 on either sides. So that is what we need to do. Once we do that, if we have 22.5 on that side, if you have A there, and then we have on the other side, we have 22.5, automatically the point of intersection of this line, this will be point C, to be there. So we go directly to, I will take a ruler and a pair of compasses. So draw straight line for these. So start with the baseline. So draw straight line. So let me extend this line because I have to make some marks. So mark that one as point A. So that is point A. So I need 6 centimeters. So my pair of compasses here is calibrated. So there is a measurement indicated there. So 6 centimeters. 6 centimeters will be there. That is 6 centimeters. So they mark an arc here. So this will be B, 6 centimeters. So from there, I want to construct 22.5 at A. I remember following the sketch there. So 22.5. So stand at A. Standing at A, using an, how to construct 90 degrees. I want to construct 90 degrees. So with any suitable radius there, mark an arc there. And then on the other side again, mark an arc there. And after you've done that, now from there you can simply adjust. Now just stand on this point. You made that arc. Then you mark an arc there, and you can mark another one here below. Then with the same radius, stand at the other arc, that point, and cut that arc. And then you cut the other arc there. Then from there, that is 90 degrees. That will be 90 degrees. So that will be 90. That will be 90 degrees. So now you need to bisect 90. You need to bisect 90. So you stand at this point. Then using a suitable radius there, you cut that point. You want to bisect this, and then that arc there. So from there you can adjust. Then stand on this arc, mark that arc there, and then stand on the other arc there and cut that arc. So I have to extend this arc here to extend that arc. So that is what is going to give us 45. Draw a straight line here. So that is 45, and that is 45. Then from there you bisect again. You bisect 45. You bisect this one here. So let me bisect these. So stand at that point, mark an arc there. Then below there, cut that arc. So you can adjust from there. Then stand on this arc, mark an arc there, and then stand on this arc here, then cut that arc. Now that is what is going to give a 22.5. So now on joining that one, you can see that is a 22.5, exactly 22.5. So this angle is 22.5 degrees. Then after doing that, the other thing that you need to do is to do the same thing at point B. We have to construct 90 degrees. Then again, we bisect that until we have 22.5. So we'll do that very fast. So we stand at B. Then you mark there, and another one. Be very careful with these arcs. There's so many. Mark that arc there. Then from there, we'll extend. So stand on this arc. Then mark an arc there, the top. Then another one here, the bottom. Then standing on this, the arc, cut that arc. Then you cut that arc. So that is 90 degrees. So after getting 90 degrees again, we bisect 90 degrees. So standing in that point, so I will mark an arc here, note the arcs I'm making, and then another one here. Then from there, stand on this arc, mark an arc there, then standing on this arc here, cut that arc. So you need to be very careful with these arcs. There's so many. Then the point of intersection is there. So you join that using a straight line. So from this point here, so that will be 45. So remember, this angle is 45. So the other one that is remaining is the one that I want to bisect. So I continue and bisect that. Now I'm bisecting the other remaining 45. So for this one, allow me to mark a big arcs. So I'll make an arc there and another one here. Then standing on this arc like that, and then standing on the other arc, you cut that arc. That is it. So after marking those arcs, and check the point of intersection is there, you need to this point. So that is the angle 22.5. So this is angle. This is 22.5. You can see that. So point C. If you look at this one carefully, point C is here. So point A is here, point B is here, and point C is there. So let me mark point C. Point C is there. So we've done that. You can see that this side AC is equals to BC. So the triangle is complete. Now we go to the next part. On one side, only construct the locus of P such that APB is equals to 67.5. APB is equals to 67.5. Now for that part, we shall use the knowledge from the angle properties of a circle, whereby we say the angle subtended at the center by chord is twice the angle subtended at the circumference. And this is how we're going to have it. So because this one is the angle that is here is 135, to have the angle that is half of that, the circumference, we're going to use this one as the center of the circle, this point. So using this point here, point C will be the center of the circle. We shall draw a circle, but since we require it on only one side, we shall have the circle that way. So this will represent the locus P. That means any angle that we make with AB as the chord to the circumference, this angle will be half of 135. Half of 135 is 67.5. So any angle that we make on the circumference there using chord AB, this angle will be 67.5. So the angle subtended at the center will be 135. So the angle subtended at the circumference by this chord AB will be half the angle subtended at the center. So that is what we need to do. So using point C as the center, we shall simply construct a circle. So using point C, so that is point C. So we're going to use that one as the center. Then we just need to position pair of compass for it to touch either point A or B. And then from there you draw a circle. You can see the circle touches point A and B using C as the center. The angle at C is 135. The angle that will be subtended anywhere along that circumference will be 67.5. Therefore, the locus of point P will be on this arc. So this is where this will be the locus P. So that one is done. So we have angle APB. So any angle that is going to be made from A to the circumference, then to B, will be 67.5. So the locus of P will be anywhere located on that part of the circumference. Now part 2, the area of triangle APB is equals to 9 centimeters squared. APB, already we have located P to be anywhere along this arc here. So now we need to have a triangle. Any triangle that we make with AB as the base, AB will be the base. So one thing that we need to identify so that we can know the position, exactly where P will lie anywhere on this arc that we've drawn here. Since the area is given as 9 and we're using AB, remember how we get the area of a triangle? It is half times the base. The base is AB, which is 6. What we need to get is the height. We need to get the distance now from AB. The distance from AB, that is the height that we need to get. So to give us 9. So this one will simply be 3h is equals to 9. So h will be 3. So we require to have a triangle of height 3 centimeters and base 6 centimeters. That will give us now the area of APB to be 9 centimeters. And actually, P will be located at points, some 2 points on that circumference. So we need to have to just stand at A, and then we shall get that measurement of 3. Let me just demonstrate that on using a sketch that we have here. So what we need to do is simply get a line that is 3 centimeters, that distance there. So this distance here, that will be the height, and you have identified that one as 3 centimeters. So with this, point P will be on the intersection. And say this intersection, P will be here and here, the point of intersection of this line and this arc here. That is where P lies. So point P, our first P will be here, the second P will be there. So the height should be, so we need to construct a line that is parallel to AB, and this is the line, and it should be 3 centimeters from AB, 3 centimeters from AB. So that is a parallel line to AB, and the distance between the two lines should be 3 centimeters. So how do we do that? So now to draw a line that is parallel to AB, and it is the distance between the two lines, that is AB and the line that you're going to draw there, to be exactly 3 centimeters, you'll check the perpendicular distance between the two lines. So you can see already we had a perpendicular, this one is a perpendicular line. Remember the distance between two parallel lines should be constant. The perpendicular distance between two parallel lines should be constant. So therefore, so there is this distance here, this is a perpendicular distance, and also this one is also perpendicular distance since we constructed an angle of 90 degrees. So we simply need to take a measurement of 3 centimeters from that. You just need to take 3 centimeters. So measurement of 3 centimeters. Then we see where P will be. So just take a ruler because already the distance is perpendicular. There will be no issue with that. So 3 centimeters. So you can actually see that is 3. So from this point, so therefore this point here. So mark that point. That is 3 centimeters. And then the other perpendicular distance, that one again will pass through here, pass through there. So that is 3 centimeters. So after doing that, now you can join. So now having that, you can join. So that is the line. So that is the line. So you can try to extend that line so that you can see it properly. So the line is there. And now the positions of P will be here and here. So let me indicate the positions of P. So these will be P1, and then this is the one here will be P2. So now you have located the positions. Now any triangle that you make with from A to P1 to A to B, and from A to P2 to B, that triangle will have an area of 9 centimeters squared, since we have calculated the height to be 3 centimeters. Now the other, so we have therefore located P1 and P2. It satisfies the two conditions above, that APB, remember A, P1, B, that one will be 67.5. We did that. The angle subtended at the circumference is half the angle subtended at the center. Or simply the angle subtended at the center by this chord AB will be twice the angle subtended at the circumference. AP2B will be 67.5, and then the area of triangle APB will be 9 centimeters squared. Now the other question is measure the distance P1, P2. The distance P1, P2, that one will be, look at mine here will be, that is 5.5. That is giving something to do with 5.5. Now that is 5.5, exactly 5. You can confirm with yours. That is 5.5 centimeters. 5.5 centimeters. So this one is 5.5 centimeters, and that is simply how you're supposed to solve that question. Thank you.